So, software maintenance, let us continue with our previous discussion. Now we see the management of maintenance. So, this is the model of maintenance effort. The model of maintenance effort, this is the expression M is equal to P plus K to the power C minus D, where M is the total maintenance effort over entire life cycle. This P is the productive effort, that is analysis, design, code and test. This K is empirically determined constant, while C is the complexity due to lack of structured design and documentation. And D is the degree of familiarization with the system. This is how you compute the model of maintenance effort, maintenance effort. So this cost of maintenance increases exponentially, as it says. The costs are reduced by structure development, and the costs are reduced by giving the maintenance team time to become thoroughly familiar with the system. So what affects the maintainability of an application? First of all, applications age. That is, older programs are probably worse written and have probably been patched more. As far as size is concerned, which is measured generally in KLOC, number of input-output files, these are the size governing factors. Then programming language. 4GLs are supposed to produce more maintainable code than 3GLs. These are third generation languages. These are fourth generation languages. Then processing environment. Files harder to maintain than databases, and real time harder than batch. Analysis and design methodologies. Well-designed software is supposed to be much easier to maintain than the not well-designed software. Structured programming. There is conflicting evidence whether this really helps. Well, if you program it better, it is always good. Then modularization. The central thesis of all the object-oriented techniques. Small, reasonably self-contained pieces of code should be easier to maintain. These small code, contained pieces of code are good. Large codes, they don't work actually. And documentation generation, maintenance of documentation is an expensive, in comparison to the maintenance of code. What I'm trying to speak is the maintenance of documentation is as expensive as maintenance of code. So if you do, or if you perform good documentation, if you document properly, your maintenance of code will be far less and less expensive. So end user involvement is also there. Some researchers believe when end users are more involved, the maintenance actually decreases. Then maintenance management, scheduling, and the attitudes of management to these two affects productivity. Now, there are problems in managing this maintenance. What are these problems? First of all, you have changing priorities, means chaotic nature of maintenance request. The length of maintenance task may cause new requests to come along before an ongoing task is actually complete. Then inadequate testing method, that is lack of time set aside for testing of comprehensive test data, of rigorous testing requirements as a standard for signing off. Then performance measurement difficulties, that how do you measure individual or group performance. The system documentation, which is incomplete or non-existent. This training takes a long time for learning an application, so programmer gets stuck on one piece of software. And adapting to the rapidly changing business environment, hardware and software also become obsolete. So from survey of 60 US and Canadian companies in Software Maintenance News 1992, we find, and the theories have found that these are the consequences of the lack of mature tools and techniques for software maintenance and its management. So everywhere the software maintenance takes its place and role. So we need predictive models of maintenance to estimate how much effort needs to go into it. By and large, maintainers work in isolation and are not closely managed. So each one has to learn from personal experiences good methods of working. Maintenance prediction is also there. Maintenance prediction is actually concerning with assessing which parts of the system may cause problem and have high maintenance cost. The change acceptance depends on the maintainability of the components affected by the change, and implementing change degrades the system and reduces its maintainability. And maintenance costs depend on the number of changes and cost of changes, which again depend on the maintainability. So, predicting the number of changes requires an understanding of the relationship between your system and the outside environment. Tightly coupled system require changes whenever the environment is changed. So, we need loosely coupled system. And the factors which are influencing this relationship, they are the number of and complexity of system interfaces, number of inherently volatile system requirements, and the business processes where the system is used. So predictions of maintainability can be made by assessing the complexity of the system components. Complexity plays an important role. So studies have shown that most maintenance effort is spent on a relatively small component of system components, very small part. If this is the software, maybe this is the part where you are actually working for maintenance. And complexity depends on the complexity of the control structure, the data structure, and the procedure and the module size. So process measurement may be used to assess the maintainability, that is the number of requests for corrective maintenance, average time required for impact analysis, average time taken to implement a change request, the number of outstanding change requests. So if any or all of this is increasing, this may indicate a decline in maintainability, right? And maintenance cost also plays an important role. Usually greater than development cost means 2 to 100 times depending on the application. So they are affected both by the technical and non-technical factors. It increases as software is maintained. So maintenance corrupts the software structure, so makes further maintenance even more difficult. And aging software can have high support costs like old languages, compilers, because support is not there. So time and money, of course, is there. Organizations become maintenance bound, cannot produce new software, and customer dissatisfaction is also there. When seemingly legitimate requests for repair or modification cannot be addressed in a timely manner, and also reduction in overall software quality as change introduce latent error in the maintenance software. One change may induce some other errors. So this upheaval, this caused during development effort, the staff must be pulled to work on a maintenance task. Development people are sent to maintenance tasks. So this is the comparison of your development and maintenance cost, right? This system 1, system 2. So always you have maintenance cost somewhat for some systems. They are more than their development cost. So maintenance cost factors may be team stability, contractual responsibility, staff skills, and program age and structure. So change is a fact of life for large software. Actually, change is fact for everyone. So we require change management. So a defined change management processes and associated case tool. This ensures that these changes are recorded and applied to the system in a cost-effective way. So you have to have very good computer-aided software engineering tools. So the change management process should come into effect when the software associated document is put under the control of the configuration management team. Change management procedures should be designed to ensure that the cost and benefits of change are properly analyzed and changes to a system are made in a controlled way. Change management processes means a request change by completing a change request form, then analyze the change request. If the change is valid, what you do? Assess how change might be implemented, assess high cost, the change cost, record change request in database, and then submit change request to change control board. If this change is accepted, then you have to repeat, make changes to software, record changes to link to associated change requests, and submit change software for quality approval. Until what? Software quality is adequate and creating of new system version. Else, what you do, you reject the change request. This is a change management process. So this is a type of change request form. You have project, change request, requested change, who is the change analyzer, who the components which are going to be affected, the associated component, what are the change assessment, the change priority, and change implementation, how many estimated days it will take place, who is going to change, the implementer name, and the date submitted to quality quality people, then the configuration management, date submitted to configuration management, and if comments. This is the change control board, and this is the change request form. So now comes the qualities in maintenance. So maintenance side effects includes, there are maintenance side effects also. In this context, a side effect implies an error or undesirable behavior that occurs as a result of modification. Because if you implement some change, some other things might start failing. So the three major areas are the code, data structure, and documentation. These are the documentation side effect. These consist of the failure of a to update documentation so that it no longer matches the code. So if the user don't know about changes, frustration is inevitable. You cannot stop it, and the entire documentation should be reviewed before your re-release. Then coding side effects are also there. Any change can cause side effects, but these tends to be more error prone. A subprogram is deleted or changed. A statement label is deleted or modified, or an identifier is deleted or modified, or changes are made to improve execution performance. These are the coding side effects. And logical operators can modify files are open or closed, design changes which translate into major code changes, and the changes are made to logical test of these boundary conditions. So these may be caught in testing or cause software failure during an operation. Then data side effects. Data side effects occur as a result of modification made to the data structure. What are the error prone areas? Redefinition of local global constants, redefinition of record or file formats, increment, decrement in size of array or other data structure, modification and modification of global data, and reinitialization of control flags and pointers, then rearrangement of the parameters, especially which are dealing with input output. So this were idea about your software maintenance. Second part we have seen.